we've got a couple of things that we're going to be playing with today. We're still working with angles. We're still working with segments. The first one that I want to talk about today is a bisector. As I write this, I want to apologize. I don't have notes for you. There aren't teacher notes for this because I'm taking a couple sections and kind of jamming them together. So I encourage you to be writing some of these down. A bisector is something that's going to cut something else in half. Okay? For example, if we have a segment like that, and a point here, so I've got points A, B, and C. If these two are congruent, then that has been bisected, okay, by that line. Okay? Bi, okay, means two, like a bicycle. Okay, we got two wheels there. A biplane has two wings, two sets of wings, okay? Sector is like we've got sections. We have split something into two sections. Bisector. Okay, we split it into two. So this line here has split segment AC into two equal parts. And that's important because anything can cut it into two parts. But a bisector is going to cut it into two equal parts, which, if they have equal measure, means they are congruent. Again, congruency is going to come up a lot. Make sure that you're getting it down. Congruent means they have equal measure, which we're notating with these two very fancy hash marks, which means the measure of AB is equal to the measure of AC, which means that B is our midpoint. It's the point in the middle. I told you, I promised I wasn't going to get very fancy with the names here. It's the midpoint, the point in the middle. Being in the middle means that it's exactly in the middle. It's not just between. Yesterday in the video we talked a little bit about between. This is not just between, it's exactly in the middle. Okay? Meaning that everything on both sides are the same. The measurements are. So, if I have 8 here, and I say AB is 8, then BC is also going to be 8. But occasionally you're going to see problems where I tell you that AB is 8, but BC is going to be like x minus 6. And I'm not going to ask you what BC is. I'm going to ask you for x. Well, we know, because they are congruent, that they're equal. And we can set equal things equal to each other. That's a big trick that we do a lot in geometry. Okay? If two things are equal, set them equal to each other. But only when you know they're equal. Don't try and set things equal to each other that are not, or that you don't know, or that just maybe they are. Okay? 8 equals x minus 6. We're going to solve this by adding 6 to both sides, and x will equal 14. Okay? So that's a segment bisector. Now, it's important to point out, you cannot bisect a ray or a line, because both rays and lines go off. Okay? Ray goes off in one direction, a line goes off in both directions, and either way, if you try and bisect it, you've got infinity on at least one of those sides. So you can't cut the thing in half. Okay? Doesn't work. Bisectors are also something that comes up when we have angles. So, if I am cutting this angle into two equal parts, then I've got a bisector. Now we're going to mark that as congruent. Remember, in order to mark angles congruent, they get one arc. Okay? That's how I know that those two angles are congruent, and if those two angles are congruent, then that is a bisector. The converse here is also true. If it's a bisector, then the two angles are congruent. For almost everything we're doing here, the converse of the original statement will be true, which is how we prove things generally, is using the converse, meaning that we've just flipped stuff, if you remember from the logic unit. So if I asked you to prove that this is a bisector, then you would say, well, I know that if it's a bisector, then the two angles are congruent. The converse is true, so then what you need to do is prove that these two angles are congruent, therefore, that's bisector. So that's where converses and things like that come up a lot in geometry when we get into these proofs. I ask you how to prove something. So if I say that this is an angle of, we'll say it's like 23, then that other angle must also be 23 degrees. Okay? But just like what we've got going on over here, sometimes I'm not going to ask you for that. I'm going to ask you for x. You can't see this real great. At least I can't from 10 feet away from my computer. 23 is our first angle, and 2x minus 5 is our second angle. Okay? We set those two equal to each other because they're equal. They're the same. They're congruent. So 2x minus 5 equals 23. We'll add 5 to both sides. I recognize you can't really see what I'm doing right now. 2x will equal 28, and x will equal 14. So you got to do a little bit of algebra to solve for what x is. And in both of these problems, it happened to be 14, which was entirely accidental. Those are a couple of the really big things today. Bisectors, cutting it into two sections. So just remember that. If I cut something in half, the two pieces I have will be equal. Okay? Unlike when my brother and I share cookies, and his piece is larger than mine. We actually, in geometry, when we cut things in half, cut them in half. All right? So, bisector means we cut things in half. We've got two congruent sides. And congruent, remember, means they're equal. All right, the other thing that I want to talk about today, let me get a drawing here real quick, is when we do have two segments, two rays, two lines that run into each other, we end up having four angles formed. 1, 2, 3, 4. Okay, so we've got these four angles. And these four angles actually have some interesting properties. If I, for example, say that this angle is 115 degrees, then I can look at this second angle and say, well, this is a line, so that this angle and this angle must add together to be 180 degrees, because that's a straight line. So 115 plus what gives me 180? And that's going to be 65. So I can solve that this will be 65. Okay? So that's one of the really cool properties when we have these kinds of intersections, is I have created two angles that, because this is a straight line, have to add up to be 180, which means they're supplementary. Supplementary means they add up to equal 180 degrees. Now, we have another angle. I know that this angle plus this angle must also be 180 degrees. For the same reason, I have a straight line here. And 65 plus what equals 180? Well, that's going to give me 115. And then I get to do the same thing, and I discover this is 65. And you may have noticed already that the angles that are opposite each other end up being congruent. And that is always true, and this is one of those things, and a lot of this is true for this first section, but this is something that you are going to want to recognize immediately from now until the end of Geometry 2. They're called vertical angles. This is, remember, called a vertex. Vertical angles are the angles that are on opposite sides of that vertex. They will always be congruent. If you ever, in a problem, see that you are dealing with vertical angles, the first thing that your brain should think is, those are equal. Okay? It's going to come up a lot. This is something you want to really drill into your brain thoughts. Okay? Opposite sides of these intersections are always going to be congruent, and the pairs here, or here and here, will always add up to be 180 and are supplementary. Okay? Vertical angles especially, though. There are a lot of problems, a lot of proofs, a lot of things we're going to throw at you. That if you just remember vertical angles are congruent, will be much, much easier. We will actually, in some cases, give you more complicated problems. If you just remember they're congruent, vertical angles, you can work your way around it without some of the new stuff. This is one of the key points in geometry. Opposite angles of intersections, these vertical angles, are going to be congruent. I think we're going to stop it there. You've got enough to do the homework. I will still be in my meet all day hanging out today, so if you have any questions or need anything, please pop in. I do have a meeting at like 10:30, so I won't be available then. But most of the day, I'll be here just hanging out, ready to answer questions. So, see you in class another Monday or Tuesday.